Hi and Assalamualaikum. The purpose of this video is for our Physics 210 assignment. We would like to present chapter 4, which is fluids. These contents are including measurement of pressure, Pascal principle and application, buoyancy and Archimedes principle. Without further ado, let's get started. So, this is our video content. First is measurement of pressure that will be presented by me, Asmawani. And the second one is Pascal principle and application that will be presented by Amira Atika and Harshadania. And the third one is buoyancy that will be presented by Izzatul Shahira. And the last one is Archimedes will be presented by Ili Akila. Measure of pressure. The meaning of pressure is the force applied perpendicular to the surface of an object per unit area. From the meaning, we can have the formula which is pressure equal to force divided area. For unit of pressure are Newton per meter per second or Pascal. Next, we will know how to measure pressure. The first one is open tube manometer. And the second one is aneroid gauge or tire pressure gauge, and the third one is mercury barometer. Is open tube manometer, and there's an example. In open tube manometer, we use to measure gas pressure. It has a U-tube connected on one side to the gas flask and open or closed on the other side. For SI unit is Pascal, and there's formula which is delta P equal to P rho G delta H. Next one is aneroid gauge. Aneroid means without fluid, and term originally distinguished this gauge from hydrostatic gauge. This is for measure the pressure liquid and gas. Finally, the last one is mercury barometer. The pressure at the surface of the mercury in the vessel is equal to the atmospheric pressure.
Hydraulic power system not only help in slowing down of aeroplane on runway, but also help in the management of the flap, landing, gear, and flight control surface. An aircraft hydraulic system consists of the three critical mechanical components and hydraulic fluid. Even a small amount of hydraulic fluid help in transmitting a large amount of force. The hydraulic fluid in contact with the cylinder or piston is at the different pressure. The oil, which is at relatively higher pressure, can be pumped into the either side of the piston head. The selector valve head in controlling the direction of the fluid.
Problem 1. In the hydraulic lifts as in figure, the larger piston has cross-sectional area A 200 cm and the small piston has sectional area A 5 cm. If a force of 250 N is applied to the small piston, find the force on the large piston. By Pascal principle, pressure on the large piston equals to pressure on the small piston. Problem 2. In the figure below, the cylinder L has a mass 700 kg and a cross-sectional area of 1000 cm. Piston S has a cross-sectional area of 50 cm and negligible its weight. If the system is filled with oil of density 0.750 grams per centimeter, calculate the force required to maintain the initial position. The answer is 159.41 Newton. Problem 3. A barber raises his customer's chair by applying a force of 150 Newton to a hydraulic piston of area 0.01 m. If the chair is attached to a piston of area 0.1 m, How massive a customer can the chair raise? Assume the chair itself has a mass of 5 kilograms. If the chair has a mass of 5 kilograms, thus the maximum mass of a customer in the chair must be 148 kilograms.
Next, we will learn about Archimedes principle. What is Archimedes principle? Archimedes principle is an object that is completely or partially submerged in a fluid experiences an upward buoyant force equal to the weight of the fluid displaced. The buoyant force is due to the displaced fluid.
Next, we talk about the topic of buoyancy. The buoyant force that caused by the pressure difference between the upper and the lower surface of the submerged block. Buoyancy is the upward force exerted on an object completely or partially immersed in a fluid. Due to buoyancy, a body partially or completely submerged in a liquid appears to lose weight. Buoyancy causes object to float. Here are the formula to calculate the buoyant force. We have Fb equals to rho gv. Fp is equal to buoyant force, while rho is equal to fluid density. G is referred to acceleration due to gravity, and the last one is P, fluid of volume. As we can see here, the unit for buoyant force is Newton, while unit for fluid density and fluid volume is the same, which is kilogram per meter cube. And the last one is unit for acceleration gravity, which is meter per second square. Here are the some of daily application of buoyant force. We have pool, life jacket, iceberg, and boat. All of these examples are the same, which is float on the surface of the water.